Tonight, the solar system seems to hold its collective breath. 3I Atlas, the third confirmed interstellar visitor, is hurtling past Mars at a hair-raising 0.19 astronomical units, roughly 28 million kilometers, while every Mars orbiter pivots to track it. But this isn't just another flyby, it's a cosmic test, a rare window into a visitor from beyond our sun. From Earth, instruments are powerless. The comet's blazing emerald coma, its sporadic microaccelerations, and the unusual carbon dioxide-rich chemistry have already upended everything astronomers thought they knew about comets. For the next few hours, only the Martian orbiters stand between us and the secrets 3I Atlas carries. Could this be a natural phenomenon, or is it something far more extraordinary? Something that challenges the very definition of alien. As the countdown ticks down, every hint, fragmenting chunks, irregular brightness pulses, spectral anomalies, might rewrite the textbooks. The window is brutally short, 6 hours. Soon, 3I Atlas will vanish behind the sun from Earth's vantage point, leaving Mars as the only outpost capable of observation. Every major orbital asset, MAVEN, Mars Express, ExoMars TGO, shifts into high alert mode, each team running rehearsed protocols while improvising on the fly. In MAVEN's control center, the so-called Red Watch team takes charge, their nerves steady but alert. These operators are specialists in chaos. They've run drills for every conceivable contingency, from sudden tail fragmentation to unexpected bursts of gas. In the hours leading up to the blackout, they meticulously rehearse switching from routine science operations to burst mode spectroscopy, ready to pivot the moment a flare or anomalous signal appears. Cross-checks with TGO and Mars Express staff are constant. Every command is double verified, every packet of data duplicated. Failure is not an option. The schedule leaves no room for hesitation. Mars Express snaps broadband images every few minutes, stacking exposures to catch even the faintest signs of a fragmenting nucleus or unexpected trajectory shift. TGO spectrometers sweep the comet's coma for any spectral lines that defy expectation. MAVEN sensors, from particles to magnetometers, watch for disturbances in the Martian ionosphere, any ripple that might suggest something unnatural. Resources are stretched to the breaking point. Observation slots are carved down to the minute, with safety contingencies always in play. If debris threatens an instrument, Mars Express can switch into protective, safe observe mode, sacrificing some data to save the craft. The abort threshold is razor thin, just 30% above the last measured spike in density. This blackout isn't a pause, it's a test of planetary science at its most extreme. From the control rooms, the Red Watch Coalition orchestrates every move. Commands, telemetry, and priority decisions flow through tight relay windows. Surface assets like Perseverance and Zhurong are in the loop, ready to provide supporting observations. Outside, amateur observatories and global networks listen, their operators poised to capture the first photometric spike and share data instantly. Every second counts. In this brief cosmic theater, humans and machines converge, racing against time and distance to catch a fleeting visitor from another star. The tension is palpable, the stakes immense, because for the next few hours, Mars is the only eyes on an interstellar traveler that could redefine our understanding of the universe.
For these 6 critical hours, the fate of our understanding of 3I Atlas rests entirely on a handful of orbiters and the teams guiding them. Every command, every observation carries weight. The margin for error is vanishingly small. This is a test of both human coordination and technological endurance, as Mars becomes the only observatory for a fleeting interstellar enigma. Since its discovery, 3I Atlas has defied expectation at every turn. The first hints of its strange behavior came not from major observatories, but from a backyard telescope in Pune, India. Citizen astronomer Priya Rao noticed a repeating pulse in the comet's light curve, brightening and fading with a rhythm no standard comet could produce. Her discovery captured attention, and as professional telescopes joined the watch, the anomalies only multiplied. Photometric data revealed brightness surges at regular intervals, too precise to be explained by random outgassing. Each flare rises sharply and fades cleanly, like a switch being flipped on and off by an unseen hand. Even as 3I Atlas approached the Sun, the periodicity remained steady, unaffected by distance or glare. Spectroscopy delivered another shock. Water vapor, the usual marker of cometary activity, was minor. Instead, carbon dioxide dominated, with ratios exceeding 8:1, a level so extreme that laboratory models struggle to reproduce it. The comet's glow is no less extraordinary. Across every instrument, the emerald green light peaks at 516 nanometers, unmatched by familiar comet molecules. Nickel emissions shine unusually bright, outpacing iron by factors of 4 or more, a reversal of the elemental ratio seen in every solar system comet. Imaging and polarimetry add further intrigue. The comet exhibits a deep negative polarization branch, more characteristic of certain asteroids than icy wanderers. Dust tail measurements deepen the mystery. Grains are larger, slower, and spread in broad, controlled arcs defying conventional comet jet models. Astrometric tracking reveals tiny course corrections, micro-accelerations that do not align with any known outgassing profile. Strikingly, each nudge coincides with a brightness pulse, hinting at a subtle link between light and motion. Alone, none of these anomalies are conclusive. Taken together, however, they paint a picture of a cosmic traveler that refuses to fit any simple category. Photometry, spectroscopy, polarimetry, and astrometry converge to form a dossier of mysteries that challenge the standard understanding of cometary physics. To explain 3I Atlas, scientists began with the basics, physics and chemistry. From there, 4 main hypotheses, each grounded in established models, have been tested against the growing evidence. Yet with each observation, the object seems to push the boundaries further, leaving astronomers both awed and perplexed, watching history unfold in real time. Scientists have proposed several natural explanations for 3I Atlas's strangeness, each rooted in the physics and chemistry of comets. The first centers on extreme chemistry, forged in deep cold. In this scenario, 3I Atlas was born far from any star, where water freezes out and carbon dioxide, carbon monoxide, and exotic ices dominate. While Oort cloud comets hinted at unusual ratios, none have matched Atlas's staggering 8:1 CO2 to water balance. Yet defenders of this view argue that interstellar space is vast, and a single outlier could reshape the boundaries of cometary chemistry. A second possibility looks to structure. Beneath the crust, pockets of trapped volatile gases could erupt as sunlight penetrates layers of ice. Unevenly distributed, these reservoirs might explain the rhythmic pulses in brightness. Laboratory models show that even slight temperature changes can trigger sudden, repeating jets. Rare, but not impossible for a body weathered over billions of years. Dust behavior offers a third angle. The comet's emerald glow and unusually large, slow-moving grains may result from unique compositions or sizes. Solar wind combined with Mars's weak magnetic field could shepherd these particles into broad arcs. In some tail geometries, heavy grains lag, drifting in sweeping curves that mimic measured bursts. The negative polarization branch, more typical of asteroids, hints at dense, carbon-rich grains rather than fluffy ice. Finally, some scientists point to the limits of our models themselves. With only 2 previous interstellar visitors, every new object tests the edge of simulation. Microaccelerations and synchronized pulses might reflect subtle interactions between sunlight, outgassing, and tumbling motion, physics not yet captured in our software. From this perspective, the anomalies are a reminder of how much remains uncharted, not evidence of intent.
During the critical 6-hour window, Mars becomes the solar system's only observatory. 3 orbiters, MAVEN, Mars Express, and ExoMars TGO form the backbone of observation, each bringing specialized instruments. MAVEN sweeps the sky with its ultraviolet imaging spectrograph, monitoring for faint emissions, fragmentation, or sudden outbursts. Its particle counters and magnetometers track disturbances in the ionosphere, any spike in charged particles or magnetic twists hinting at something beyond natural chemistry. Mars Express focuses on visual imaging, stacking broadband exposures to capture the comet's evolution and watch for fragmentation or shape changes. Its spectrometer scans from ultraviolet to infrared, hunting for unexpected spectral lines or missing water signatures, while its plasma analyzer looks for energetic ions signaling abnormal interactions with the Martian environment. ExoMars TGO complements these efforts with NOMAD and ACS spectrometers, probing for trace gases, isotopic ratios, or molecular fingerprints that deviate from solar norms. High-resolution cameras aim to catch dust jets or fragmentation events in real time. On the surface, Perseverance and Zhurong rovers provide backup, monitoring for dust fallout, atmospheric changes, or even faint auroras. Though less sensitive than orbiters, they add another layer of verification. The protocol is meticulous. Any observed anomaly, fragmentation patterns, trajectory shifts, unexpected emissions, or synchronized pulses must be confirmed by multiple instruments before it enters the scientific record. Data redundancy is paramount. Every packet relayed from orbiters is duplicated, timestamped, and logged across independent ground stations on both sides of the Atlantic, ensuring no critical clue is lost. In this tense, coordinated dance, every observation counts. For 6 hours, humanity's gaze is fixed on Mars, hoping these orbiters can unlock the secrets of a comet that refuses to fit into any known category. A visitor from the stars that could challenge everything we thought we knew about interstellar objects. The system guarding Mars's observations is designed for perfection. It shields against solar interference, transmission errors, and the rare risk of data corruption during the blackout. Telemetry can take hours to reach Earth, bouncing through relay satellites and deep space antennas, adding tension to an already razor-thin margin for error. Mission teams prioritize anomaly packets, any sign of fragmentation, spectral outliers, or abrupt trajectory shifts, routing them through rapid verification routines. No single sensor, no single team can confirm an alert alone. Each event is checked by at least 2 instruments, with raw data uploaded to open archives as bandwidth allows. The chain of custody extends beyond numbers. If an orbiter's collector catches a dust grain or ice fragment, planetary protection officers step in. These specialists enforce strict handling. Samples are sealed, barcoded, and logged with digital hashes, requiring approval from both NASA and JAXA before any analysis proceeds. Provenance is critical. Any organic signal detected later must be traceable, distinguishing what came from 3I Atlas and what is native to Mars. Even metadata, time, location, and instrument calibration is recorded in tamper-proof ledgers, ensuring anomalies can be audited decades from now. Outside control rooms, a parallel network hums with activity. Citizen astronomers from Pune to Arizona upload photometry and astrometry to shared databases. Often the first alert comes from these amateur observers, yet professional teams immediately triage the data. Only after multiple cross-confirmations do official bulletins emerge. Extraordinary claims demand extraordinary evidence, and messaging protocols stress transparency without hype. Trust, verification, and redundancy govern every step. Within the Red Watch control room, the decision matrix is the nerve center. 3 branches, conservative, hazardous, and extraordinary, define responses. Conservative holds if anomalies align with rare but natural comet behavior, volatile pockets erupting, dust grains shaped by unusual chemistry, or microaccelerations within known physics. Hazardous triggers if fragmentation, mass loss above 10%, or unpredictable shifts threaten Mars orbiters, prompting safing procedures. Extraordinary requires at least 2 independent, statistically significant anomalies. Synchronized pulses paired with microaccelerations or spectral lines defying known chemistry, confirmed by multiple teams and instruments. No single signal suffices, only converging evidence opens the door to extraordinary possibilities. Every operator knows the stakes. Every data packet climbs a rapid release ladder, public within hours instead of months. NASA, ESA, and JAXA now mirror archives, releasing raw and annotated data once integrity is confirmed. Automated pipelines flag outliers for immediate review, while calibration notes accompany the numbers. Emergency procedures include high-cadence relays during transient events, followed by full-resolution spectral and image dumps. Citizen scientists are fully integrated. Amateur networks from Pune to Patagonia feed data into vetted pipelines, triaged by machine learning routines to trigger professional scrutiny within minutes. Planetary protection protocols ensure anomaly tags on every biosignature and full chain of custody logs for dust or organic material. These measures don't just prepare for 3i Atlas, they establish a blueprint for every visitor from beyond the sun. On October 3, 2025, as 3i Atlas skimmed just 0.19 astronomical units from Mars, every orbiter and rover turned skyward. Over 40 hours of high-cadence data streamed from MAVEN, Mars Express, and ExoMars TGO, capturing the comet's emerald glow, pulsed brightness, and unusually CO2-rich spectrum, signals unlike any seen from known comets. While many features can be explained naturally, the microaccelerations and synchronized pulses remain unexplained. The data, released publicly, now allow the world to witness this interstellar encounter in unprecedented detail. Yet the questions linger. What truly caused the emissions, and could any engineered activity be at play? Regardless of the answers, the Mars flyby of 3i Atlas has transformed how humanity observes, analyzes, and prepares for cosmic visitors. It has set a new standard in transparency, cooperation, and scientific rigor, forever changing our approach to the mysteries arriving from beyond our solar system.